We're going to talk about terminal velocity. What is terminal velocity? Terminal velocity is the uniform or constant velocity attained by a solid particle which is falling through a viscous fluid. Now, a sphere falling through a viscous fluid soon acquires a steady velocity. This velocity is called terminal velocity. This was first demonstrated by the 19th century British mathematician Sir George Stokes. Stokes discovered that a body falling through a viscous fluid experiences an upward retarding force V, are we there? Which is dependent upon the radius of the sphere, its velocity, and the viscosity of the fluid. There is also the weight of the sphere acting downwards, mg, and the upthrust, u, of the liquid, which acts upwards. Now, Stokes related these forces with a law, which is popularly called Stokes' law, which states that a small sphere falling through a viscous medium acquires a uniform velocity given by V is equals to 2 all over 9 r squared g all over coefficient of viscosity, open bracket, rho 1 minus rho 2, where r is the radius of the sphere, g is the acceleration due to gravity, and this is the coefficient of viscosity of the fluid, rho 1 is the density of the sphere, and rho 2 is the density of the fluid. We can therefore write the equation of motion of the sphere as mg minus v minus u is equals to na. Are we there? Where a is the acceleration of the sphere through the fluid, and m is the mass of the sphere. Now, as the sphere continues to accelerate through the fluid, the speed v increases, and so does the viscous force v. At a stage in its motion, the viscous force v becomes proportional to the velocity of the sphere. That's small v, the big capital V is proportional to small v. Therefore, v is equal to kv. That is, the viscous drag equals the downward force of the weight of the sphere. Now, at a particular period, the sphere ceases to accelerate, and therefore, this equation, mg minus v minus u is equal to na, where m is the mass. Acceleration becomes 0. So we can rewrite this equation as mg minus v minus u equals to n times 0, which gives you 0. All right? So I'm going to take this v to this side. So I'll have v is equals to mg minus u. All right? Where v is the terminal velocity. V is the terminal velocity. Mg is the weight of the sphere falling through the viscous fluid. U is the upthrust of the fluid on the ball. Are we there? Now, raindrops often attain this terminal velocity before reaching the ground. The acceleration of the rain is often opposed by the viscous drag of the air. Otherwise, raindrops will reach us with very dangerous striking velocity. Now, I'd like to thank you very much for your time. For more of this work, you can visit the book P Physics. In the next section of our work, we'll be taking on calculations and friction. Thank you very much.